Hello and good afternoon, dear students, and welcome to the new episode, which is directed to the Cambridge IGCSE candidates. In this episode, I'm going to solve 6 different questions from paper 3 and paper 4. And these questions actually are topic questions. The topics are particles, atomic structure, ionic bonding, and the periodic table. So let's start with the first question. Here in this question, the structure of some substances containing chlorine are shown. We have in the first compound tetrachloromethane, and the second compound chlorine, and the third compound it's potassium chloride, and in the fourth one D, it's actually let's name it, it's 1,1,1 trifluoro 3,3 dichloropropane, and in the last one actually it's 2 molecules are bonded and both of them are aluminum chloride. Okay. So the question A, answer the following questions about these substances. Now, which substance is a diatomic molecule? It's very clear, it's B, diatomic. That means it's made from 2 atoms. Which substance, next question, which substance represent part of an ionic structure? Ionic, that means you need to have positive ion and negative ion, cation and anion. So it's very clear, it's C, potassium chloride. And question III, which substance is an element? It's an element, that means doesn't form from different elements. So again, it's B. Why it's B? Because it's made from one type of element. So it's B, made from one type of element. Okay. In the next question, determine the simplest formula. Simplest formula doesn't mean it's the empirical formula. No, simplest formula, just you need to simplify this compound, which is this one. Now, how many carbons you have? 3. How many hydrogen? It's 3. Okay. Then fluorine also 3, and 2 chlorine. So C3H3F3Cl2. C3H3, sorry, it's F3 and Cl2. This is the simplest formula. Next question, which is about isotopes, proton and electron numbers, neutron numbers. So the symbol for 2 isotopes of chlorine are shown. Both of them, they have 17 protons, and the nucleon number, it's actually are different, 35, and the other one is 37. Now, how do these 2 isotopes differ in their atomic structure? The difference only differ in neutron number. Okay, they are different in neutron. This 35 and here should be written like this, 35, 17. Okay. Now the next question, determine the number of neutrons present in one atom of the isotope. Always you need to subtract 17, which is the atomic number or proton number, from the nucleon numbers. That means 35 minus 17, and this one it will give us 18 neutron. Draw the electronic structure of a chlorine atom. Show all shells and all electrons. So here, chlorine. So chlorine in the first level energy, you have 17 proton, that means 17 electron. So 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, and the last level energy with 7 electron. Okay, here you have single electron. Okay, so this it's called the cross diagram. Okay, and this one it's extra, just you need to show. I will show you the simplest electron configuration for these 17 electrons, 2, 8, 7. This equation is totally similar to the previous one, but we have different compounds. The structures of some substances containing phosphorus are shown. This one is called phosphine. The other one, B, it's called this one, it's called pH4 iodide. So this one, it will be phosphonium iodide. And the C, actually this one, it's the molecule of phosphorus, because phosphorus is always exists as 4 atoms. And D, it's sodium phosphide. And the other one, it's how many phosphorus? It's 3. And how many oxygen? 3. So 6p3 or 6. Okay. This one is phosphorus oxide, the E. Okay, now question 1a. Answer the following question about these substances. Which two of these substances are ionic? Ionic, as we have said, it's negative, and so this one, there is positive and negative, and here positive and negative, so it's D and B. Next question. Which one of these substances is an element? The element should be made from one type of atom, so it's C. C, made from one type of atoms. Okay, determine the simplest formula for substance D. Here you have phosphorus is -3 and it's surrounded by 3 positive ions, so it will be Na3P, because this one is -3 and this one +1. So this is the simplest formula. Next question. Phosphorus has one naturally occurring isotope. Here, this one again, it's just phosphorus. So 31, 15. Okay. Now, determine the number of neutrons present in one atom of the isotope. So 31 minus 15, and this one, it will give us 16 neutron. How many electrons are there in the outer shell of one phosphorus atom? Now you have two options to solve this equation. Maybe you will go directly to the periodic table and you will see phosphorus in the group number 5, so at once you will write 5 electrons, or you will arrange these electrons by writing their electron configuration. So these 15 electrons, so you will say 2, 8, 5. So in the outer level energy you have 5 electrons, so you write again 5 electrons. III, determine the total number of electrons present in a phosphorus molecule P4. In one phosphorus, like this one, you have 15 protons. That means how many electrons? 15 electrons. So if this phosphorus is timed 4, that means you have 15 electron times 4, which is 60 electrons. Sorry. What type of oxide is phosphorus oxide? Phosphorus oxide, it's acidic oxide. Acidic oxide. Why? Because it's non-metal oxide. Okay, non-metal oxide. That means this non-metal oxide, its solution, or when it reacts with water, it will give us acidic solution. So we have considered as acidic oxide. Next question. The structure of sodium chloride and nitrogen are shown below. This is sodium chloride and this is nitrogen. Describe. Look at here, please. You need to be very careful with the request of the question. So here you have to talk about structure and the bonding. Then volatility and electrical conductivity. So this is for first one, sodium chloride, and this one for nitrogen. Now, what's the structure of the sodium chloride? It's giant lattice. The type of bonding, it's ionic. Their volatility is very low. Very low, because the boiling point is very high for sodium chloride. Conductivity doesn't conduct. In which state doesn't conduct? In a solid. So here I will summarize it. In a solid, doesn't conduct. In a molten or liquid, conduct. In aqueous, conduct. This is in the electrolysis. Okay. Now let's go to the nitrogen. Nitrogen, how is it? It's simple. It's not giant, simple molecular. The type of bonding, it's covalent. Simple covalent, you can say, or covalent. Volatility is very high because it's gas. High volatility, and doesn't also. Doesn't conduct electricity in all the state of matter. Solid, liquid, gas, it doesn't matter, because here it's formed from non-metal, so there is no conductivity here. This is for your level, okay? Then ammonia is manufactured by reacting nitrogen with hydrogen using a catalyst. What's the purpose of the catalyst? Only speed up the reaction, or increase the rate of reaction, okay, without involving in the chemical reaction, or without any chemical change. Okay, that means you may use the catalyst again in the next reaction. Here, complete the chemical reaction. For this chemical reaction, it's called Haber process. Just you need to balance. Here you have 2 atoms of nitrogen, here 1, so this one's times 2. In this case, you have 6 hydrogen atoms, here 2, this one should be 3. So now it's balanced chemical equation. Then you have cross and dot diagram. You have to complete the electronic structure of the molecule of ammonia. Now, again here, you have to have a look to the periodic table. You will see the nitrogen in a group number 5. In this case, you have 5 electrons around the nitrogen atom. So here, the one which is shared should be single electron. 1, 2, 3, 4, and this one 5. Hydrogen, each hydrogen has 1 electron. So in this case, we have completed the cross and dot diagram for ammonia molecule. Ammonia reacts with copper oxide. Which compound is reduced in this reaction? It's very clear. Here the best option for you to know which one is reduced, that means the one who is losing the oxygen. So copper, you need to say copper. Okay, as a word we can write it, then we will explain it. Copper. Why? Because look at here, to the copper has oxygen, then it lost the oxygen. That means this one, it's reduction. Or you can say the copper, it's positive 2 here, but here it's 0. That means this one gain 2 electron. So gaining of electron also it's reduction. So you have 2 options to explain why copper is reduced. So this is a question for paper 3. So at the end of this this paper, you may have a look to the mark scheme, but now let's complete the other part, which is paper 4. We have also 3 questions about the same topic. Here, the table below gives information about particles. Complete the table. The first line has been done for you, for A. Has been done already. Okay. What's B? Now, what's the number of proton? Look to the B. B, it's not neutral atom, it's ion. Here it's -1, that means number of electrons more than the number of proton in what? In a 1. So number of electron, it's 18. So the number of proton should be 17. In the C, again, you have to look to the charge on the particle. How is it? 0. That means here proton equal to electron. And D, look to this one. We don't know what's the charge, but you have the number of proton and electron. Number of electron more than proton in a 2, so at once it's 2 minus. Okay, so what's the electron configuration of 10 electrons? It will be 2, 8. First level energy 2 and the second level energy, it's 8. Gallium is a group 3 element. Define the term element. Element, that means a substance, we can say. Substance a substance which is doesn't broken down by chemical means or reaction. Okay. Or you can say an element which it contains same number of a proton, okay, which is equal to the atomic number. So this is just a very simple question element, and you may there is actually more than one definition of the elements. You will have a look at them in the mark scheme. The following are gallium atoms. There is a difference in the nucleon number, so they are isotopes. So here we have this table, we need to fill it out. So what's the number of proton? Proton always same atomic number, so 31. Okay, number of electrons, they are neutral, they are 0, both of them. So number of electrons, number of both of them are same, but they have different number of nucleon number. That means different number of neutrons. So here 69 minus 31, it will be 20. 69 minus 30, 69 minus 31, it's 38, and the other one it will be 40. Next question. They are very simple questions. Protons, neutrons, and electrons are subatomic particles. You may find them inside the atom. Complete the table to show the relative mass and relative charge of proton and a neutron and an electron. Only for electron it's already done. 1/1840. The relative mass of proton and neutron are equal, 1 to 1. Relative charge of proton positive, neutron neutral, 0, and electron negative. Then bromine has 2 isotopes. Define the isotope, same element, but which has same number of proton but different number of neutron, or you may say different number of different nucleon number. Explain why the 2 isotopes of bromine have the same chemical properties with 2 marks. Because same electron number and same electron in the outer level energy. Okay, because 2 marks, so same electron number. Okay, it's chemical, but to be more precisely, you have to say same electron in the outer level energy, because the number of electrons they will determine the chemical properties of the substance. Here another question, which is about the number of proton, neutron, and electrons. Here protons, same atomic number, 3. Electron, it's 0, so here you have 3. Number of neutrons, 7 minus 3, which is 4. And the next one, here it's ion actually. So the number of proton it's 16, but the number of electrons should be more than the number of proton in a 2, because the charge is -2, so it's 18 electron. And the neutron, 34 minus 16, which is 18. 34 minus 16, it's 18. And the last one, just you need to figure it out which atom this one. So here we have 19 proton. Let's figure it out. X. Then you need to check it. Then 19, which element in the periodic table. But what's the charge here? It's a number of electrons less than the number of proton, so it's +1. So this one, it's actually it's 19. It's potassium. I think it's potassium. So it's how many electrons? 18. So 2, 8, 8. Level energy. Yes, it's potassium. Just let me check it in the periodic table. Potassium. Yes, potassium. So next question. Question 2. Matter can exist as solid, liquid, or gas. The arrows show some changes of state. So we have 3 changes, A, B, and C. So name the changes of the state represented on the diagram. A, it's from solid to liquid, melting. And B, from solid to gas, it's sublimation. For example, carbon dioxide, dry carbon dioxide, you can say. It can sublimate, and also this is for sublimation, and you can say also iodine. These 2 compounds, they can be sublimated. And the C, from gas to liquid, which is condensation. Explain why energy has to be supplied to turn a liquid to gas. Why? To overcome. You have a liquid, you need to convert it into gas. So to overcome the force of attraction. The force of attraction, which is a physical one. Could be van der Waals, could be hydrogen bonds. Okay, so these physical bonds or forces, we need to break down them to be converted into, for example, liquid, and liquid to gas. And here the diagrams represent the same number of particles. We have 4 particles of gas in 2 containers, D and D, which have different volume. So this one is smaller than D. The 2 containers are the same temperature, so the temperature is constant. In which container will the pressure be high? It's E. But why? Why? Because the particles sorry for that. Particles are more often hit the wall. So as the particles, they are more often to hit the wall, that means more pressure actually it's produced on the wall of the container by these particles. So the pressure is very high at the E container, which is higher than container D, because here the particles they will hit the wall of the container, but not like the number or the chance of the in the container E. So the end of this question, we have arrived the end of this session or this episode. And don't forget to check your answer with the mark scheme also. Here we have the mark scheme till the end of this PDF for this paper, and same thing for the previous paper. So I would like to thank all of you for listening and watching this episode, and see you in the next episode. See you, bye.